Howdy folks, thanks for checking in to MrUlrichsLandofBiology.com. I am Mr. Ulrich. In this video podcast we're going to be looking at the scientific method, which helps us understand and know, well, how we know what we know. Now before we get any further, I just want to take a moment to address this little phrase here. I'm just no good at science. Been at this teaching game for some time, and I've been hearing this line for far too long. It's a cop-out. It's almost completely and wholly untrue. You've been using science, you just really haven't been thinking of it as science. Use it every day. Anytime you have seen something take place and you compare it to other situations that you've seen that are similar, and you try to make note of the differences in those situations and use that to predict what you think is going to happen, you're using science. I think part of the problem is the word science. People hear that and they immediately think of really hard classes with lots of memorization and lots of words that are really long and lots of math. Science is, well, it's more than just that. It's more than just people with crazy hair in lab coats. It covers a lot of ground. Really, what science is the objective interpretation of observations. Now, what does this mean? Well, we observe stuff, right? We see, hear, smell, we sense observations, and from gathering information and from remembering those observations and putting them together into a sequence, we can start to make predictions. And when we start going from sense to predict, that's when we can start to get into cause and effect. And really, that's what we mean by science. The objective part just means that it doesn't matter how badly you want a particular effect to have a particular cause. Facts are facts. It's just how it is. Yay, science. Okay, so what do I mean by this? Alright, here you go. You wake up in the morning and you look outside and you recognize that, well, it's cloudy. And you've seen that before, clouds in the sky. That usually means rain. And since we don't like to get wet, what are you going to do? You're going to act on your prediction that you see clouds in the sky and you think it's going to rain, and you do something. You go ahead and you put on your raincoat, maybe you bring an umbrella with you. That's really it. You've made an observation, you've compared that with previous observations, you make a prediction, and there you have it. Science. If science is the objective interpretation of observations, the scientific method is how science is done. It's the sequence of steps that scientists employ in order to make sense and understand the world around us. It goes something like this. You see something cool. You observe some sort of phenomenon that's interesting enough to you that you want to go ahead and do the background research. See what other people who have been interested in that phenomenon have come up with, or related phenomenon have come up with. And then you see where there are still gaps in the understanding of that particular phenomenon. From all the background information that you've been gathering, you try to answer that question even though you're not sure. You have developed a hypothesis. Now, years back you probably were taught that a hypothesis is an educated guess. We need to move beyond that kind of middle school understanding of a hypothesis, because it misses an important part of a good hypothesis. A good hypothesis needs to be testable. If it's not testable, it's not really science. If we can't test it in a controlled experiment, we got a problem. At least with it being science. It still could be interesting and worthy of study, but we wouldn't call it science per se. We might call it philosophy. So, in order to test our prediction, we need to set up a controlled experiment. Now, we'll talk more about this later on. I just want to move through. The controlled experiment is how we're going to test our hypothesis. So we gather the data and we interpret the data and see if our testable prediction, if our prediction was actually correct or not. Then, and this is an important step, We need to peer review and publish it. We need to share it with the world. Now, it's not just so that we can let the world bask in the glory of our intelligence. It's not so that they can shower us with money, although those things are perfectly fine, and I'd appreciate that. It's also so that we can have other people who are knowledgeable in scientific method take a look at how the experiment was set up, how it was carried out, and how the data were interpreted. This is important because I may, as an experimenter, either consciously or subconsciously, kind of bias how my data are gathered, how they're interpreted, even how the experiment is controlled, and that may influence the outcome of the experiment and my interpretation of it. And so it's important to that peer review process to keep that from happening. I want to take a couple brief moments here at the end of this podcast to just describe what needs to go into an experiment for it to be controlled or good, for that matter. The first thing is that there's only one experimental variable. That means that in all the different treatments and all the different beakers and all the different setups, there's only one thing that's allowed to be different in each one. That's set up, I should say, different in each one. All of the other factors are going to be, as we say, controlled for. They're going to be held to be the same in each one of those experimental treatments. One of the treatments is going to be designated as the control. It's going to not get the experimental variable. This is what we would normally describe as normal, and it's what we're going to compare the experimental results with. Lastly, we need to make sure that the experiment is repeated. That way we can have a better chance that any differences in outcomes between the different groups was due to the difference in experimental variable and not some other outside factor or even random chance. And so that's why we're going to do some repeat. There is a video podcast up of the tiger repellent rock experiment, and that should really give you a good example of all the different ingredients for a good controlled experiment. But right now I want to stop right there because we've been going on long enough. Once again, thanks for checking in with Mr. Ulrich's LandofBiology.com. If you have any comments or concerns or questions, feedback, please, by all means, go to the website and send me an email. Thanks again, and we'll see you in class.